All right, when last we met, we were talking about exponential functions. What makes something exponential again? Anybody remember? I know with Thanksgiving it's been a couple weeks. What made something exponential? The variable is in the exponent. So we had something like y equals a times b to the x. That's what exponential functions look like. Now, this a and this b, these are something very important. Let's say we had the equation y equals 100 times 1.1 to the x. And I were to build myself a little table here. And I'm going to plug my favorite number in the whole wide world in for x. My favorite number is 0. What happens when I plug in 0? What's 1.1 raised to the 0? 1. And what's 1 times 100? It's 100. What's a very important point? What's that called when you plug in x equals 0? Well, this thing to the power is always going to be 1. And so you end up with the a number, whatever the a number is. But what's it called when you plug in x equals 0? That's a very important point on the graph. This is the y-intercept. So this a value gives you the y-intercept. So 0 comma a is always going to be the y-intercept, always going to be, in word problems that we're going to get to in a minute, it'll be your starting value in a sense. And then what happens if I plug in 1? What's 1.1 raised to the 1? 1.1. What's 1.1 times 100? 110. So what happened? I went from 100 to 110. What's that have to do with the number 1.1? How much did I gain? 10. I gained 10. That's true. How about if I plug in 2? Will I gain exactly 10 again? What's 1.1 squared? Somebody got a calculator with them? 1.21. 1.21 times 100 is 121. I didn't gain 10. How much did I gain? Gained 11. Do we expect to gain the exact same amount each time? No, that would be linear if it was. Anybody know a different relationship between 100 and 110? And then 110 to 121? This is a gain of 10. This is a gain of 11. This happens to be a gain of 10%. What's 10% of 100? 10% of 100 happens to be, so we gain 10% there. To go from 110 to 121, we also gained 10%. Because if I take 110 and multiply by 10, that would give me 11, 10%. So I gained 11. So, what's that have to do with this number back up here, that 1.1? Well, ignore the 1 for a minute. What's 0.1? That's 10%. So the base, the B number, gives you your growth or decay rate. B is the growth or decay rate. If B is bigger than 1, you have growth. So a 1.1 turns into a 10% growth rate. When do you think you would have decay? Well, I think it's pretty, if B is bigger than 1, you have growth, so when do you think you're going to have decay? When B is less than 1. Except remember, B has to be a positive number, so if B is between 0 and 1, you get decay. So let's see how that works. Y equals, it's easy to start with 100, times, give me a nice number less than 1, but bigger than 0. 0.6. 0.6 to the x. Again, if I were to plug in 0, my y value would be 100. If I plug in 1, I get 0.6 to the 1, which is 0.6. 0.6 times 100 is 60. So if I went from 100 down to 60, how much did I lose? 40, so I lost 40%. So if B is 0.6, my decay rate, how much do I lose? 40%. What if my B was 0.9? Then I would lose 10% each time. All right. So B equals 0.6 means we lose 1 minus 0.6, which is 0.4 each time. Okay, so those two facts become very important in dealing with word problems. So let's take a look at a word problem here. Suppose a flu epidemic has broken out at your school. Assume that on February 10, a total of 20 people came down with the flu, and that each day the number of people who have gotten the flu as of February 10 triples. Let f of t be the number of people who have gotten the flu at t days since February 10. Determine an equation for f of t. All right, so we're going to have f of t is a times b to the t. The A number should be very easy to figure out. What's the A number? 20. Why 20? That's how many people had the flu at the beginning. At time 0, on February 10, 20 people had the flu. So we're going to have 20 times b to the t. Now, what's b? Well, what has to happen? How many people are going to have the flu on February 11th? It has to triple. So how many people are going to have the flu? 60. So how do I make the number 20 triple? I multiply by 3. So if I have a t here, if t is 1, I get 20 times 3, that's 60. It triples. What happens if t is 2? It gets multiplied by 3 again, which means it would triple again. So I think our function is just 20 times 3 to the t. All right, then it asks, what's f at 4? What does that symbol mean to do? I plug in 4 for t, which means I triple 4 times. I'm going to have 20 times 3 to the 4th. And that's how much did you get? 1,620. 1,620. What happens on day 10? I have 20 times 3 to the 10. And that's a very big number. What'd you get? What'd you get, Jessica?
1,180,980.
1,180,980. Do you think that's believable? Probably not. Why not? It's at your school. Do you think there's 1 million people at your school? No, I don't think so. So, possibly the flu spread outside of your school, and there are now 1 million people infected, but certainly not 1 million people at your school are infected. I don't think there's any school in the world that has 1 million people in it. So the point is, exponential functions grow very fast. Only plugging in x equals 10, we're already up to 1 million. What if I plugged in x equals 11? It would have to triple again, so I'd have over 3 million, wouldn't I? Grows very, very quickly. All right, let's try the next one. The revenue from ringtones was 500 million in 2005 and has grown by about 114% per year since then. Let RFT be the revenue in billions of dollars, that is T years since 2005. Find an equation for RFT. All right, so RFT is going to be A times B to the T. Once again, the A number should be pretty easy. What's the A number? 500 million. I'm just going to write it as 500, and we'll leave everything in millions. Why is A 500? It was a starting value at 2005, so it's when time was 0. And then what's the B number? 1.14. That's a very common mistake. I'm going to put 1.14 and we'll fix it in a minute. Many people would put 1.14. That's close, but not quite right. What would 1.14 mean? How much are you growing? That would be 14%. If this is a 1, whatever comes after the decimal is how much you're growing. So we're only growing 14%. That would be 14% growth. So how do I do 114% growth? 1.114? That's not quite right either. That would be 11.4% growth. If I want 114% growth, I need to take the 1 and add 1.14. I take this and I convert it to a decimal. As a decimal, this is 1.14. So I always start with 1, which is 100% growth, and I would have to add the 1.14. What's 1 plus 1.14? 2.14. So if you want more than 100% growth, that base is going to be bigger than 1. It's going to be a 2. So we need 2.14 to get 114% growth. If we had 1.14, that would be 14% growth. All right, and then it asks some questions. I think we've pretty much already answered them. What is the R-intercept? 0, 500. What does it mean? In 2005, revenue was $500 million. What is the base B? The base B is 2.14. And what does it mean? Growth rate is 114%. And finally, part D, predict the revenue this year. Well, what year is this? 2015, and we started in 2005, so that's 10 years. So we would have R at 10 is 500 times 2.14 to the 10th. Unfortunately, I don't seem to have brought a calculator today, so somebody type that in and tell me the answer. It's going to be very large. $1,780,000. 1,007,181. 181. I got too many zeros here. 1,700,181.
That was 7,000.
All right, so 1,007,181. Like that?
Can't see
Yes, all right. See, that's why I should bring my own calculator. Once again, do you believe that number?
it. Ringtones?
For ringtones, do you believe that ringtones this year are making $100 million?
I'm in the wrong business if they are.
It's even worse than $100 million, isn't it? It's not $100 million. What is it? It's $1 million. Do you believe ringtones are making $1 million this year? No. So what happens with these exponential functions? You get model breakdown very, very quickly because they grow so quickly. So what do you think in reality happened? Do you think they've had 114% growth for 10 years in a row? No. They probably had 114% growth for a couple years, and then what do you think happened? It probably pretty much leveled out, and they probably pretty much stayed the same. Number 3. A person invests $4,000 in stocks today, and the value doubles every 6 years. Let f of t be the value of the investment t years from now. Find an equation. All right, so f of t is a times b to the t. This one's going to be a little bit different. It's not going to be quite a times b to the t. We'll see what we have to do here. What's a? A is easy. 4,000. What's b?
2 every 6 years.
It doubles 2 times every 6 years. So how do I write doubles every 6 years? Well, I'm still going to have the 2. And I'm not just going to have t. What I'm going to have instead is t over 6. Why would it have to be t over 6? Well, what happens if I plug in 6 years? If t is 6, 6 divided by 6 is 1, and I would get 2 to the 1, which is 2, so it would force it to double. So if it's doubling every 6 years, you're just going to take t and divide it by 6. If it said it doubled every 10 years, you would have t divided by 10. Okay? Find the value of the investment 20 years from now. Well, to find the value, I would plug in 20. That's going to be 4,000 times 2 to the 20 over 6. And again, I would grab my calculator, and I would get we got an answer yet? 20,000? 40,000? $317? Believable? If you invest $4,000 in a stock, you'll have $40,000 in 20 years?
It's a whole Wall Street stuff, probably.
It's possible. Not likely, but certainly is possible. For example, I know when I moved here in the year 2000. In 1999, Corning stock was selling for $135 a share. In 2000, the stock market crashed. Corning stock was then selling for $1.50 a share. So it went from over $100 a share to $1.50 a share. Today, Corning stock's around $20 a share. So has that doubled in every 6 years? It's done better than that, actually. So had I invested $4,000 in Corning stock back then, I'd have been doing okay today. Unfortunately, I wasn't that clever. So I didn't make $40,000. But it's possible. It's not likely. Stocks don't usually gain that much, but it is possible. All right, number 4. This will be my last one for the day. Then you're going to do no problem. A storage tank contains californium-251, a radioactive element with a half-life of about 900 years. Let G of T be the percentage of californium that remains at T years since the element was placed in the tank. Determine an equation of G of T. All right, so G of T is going to have A times B to the T. How much did we start with? How much was in the tank at the beginning? Doesn't tell us, does it? It kind of does, actually. Because it says, let G of T be the percentage of californium that remains. So at the beginning, how much californium, what percentage of californium was in the tank? All of it, 100%. So sneaky way there, A is 100. All right, what's B? Big clue here is it says with a half-life of about 900 years. What does a half-life mean? The time that it takes 50% of it to decay. So it's going to take 900 years for half of this to go away. So what's my B number? B number is a half, because I want half of it to go away. But then I'm not just going to have T, because that would say, if I just put a T there, that would say I lose half of it every 1 year. I don't lose half every 1 year. How long does it take to lose half? 900. So how do I fix the T? I got to divide it by 900. It takes 900 years to lose half of it. All right, and then it says, what percentage of the californium will remain after 600 years? You simply plug in 600. That's 100 times 1/2 to the 600 over 900. $63. So we still have about 63%. And what percentage of the californium will remain after 3,600 years? You plug in 3,600. You have 100 times 1/2 to the 3,600 over 900. And you get? 6.25. So after 3,600 years, only 6% remains. Then it asks, how could you have obtained this answer without using G of T? Well, what they're looking for there, the half-life is 900 years. How many half-lives is 3,600 years? That would be 4 half-lives. So you could take 1/2 times a half times a half times a half 4 times. You could have started with 100, multiplied by a half, and then done that 4 times if you hadn't written the function. Questions on that?